Welcome back. Are you ready? I think you're ready. Welcome back to your lesson episodes, and here I am, Miss Moncrief, to bring you a lesson on geometric sequences. So let's talk about let's. So we've learned last Friday we learned about arithmetic sequences and how to create an explicit equation. Today we are doing the same for geometric sequences. It's pretty much the same work. But before we get into that, we want to talk about one quick thing real quick. So we all remember the equation for an arithmetic sequence. That was a sub n is equal to a sub 1 plus d times n minus 1. Well, we want to talk about this right here, this n minus 1. What is it? Who is she? She's mysterious. Why is it n minus 1? Like, why? Why can't it just be n? Well, it can't just be n because sequences start sequences start at sequences start at, why does it do that? At term 1. So if we remember, like if we have the arithmetic sequence 2, 4, 6, and 8, 2 is our first term, not our 0 term. It's just our first. So if sequences start at term 0, it would be written more like a sub n is equal to a sub 0 plus d times n, which really just kind of looks like y is equal to b plus mx, which is our what? Slope intercept. Set form. Not a sequence. And that would really just make a sub 0 be a y-intercept, not a first term. Alright, so now that we've kind of talked about that, let's move into writing our geometric sequences. So, writing a geometric sequence is pretty much the same as writing an arithmetic sequence. So, let's start by talking about what our skeleton of a formula it is. It is a sub n is equal to a sub 1 times r to the n minus 1. You might see some things that are familiar there. We had an a sub n before, we had an a sub 1 before, and we had an n before. N minus 1 before, actually. They're just in different spots. So, let's start with this a sub n. A sub n is still the nth term. It's still the output, the dependent, or the range. I like to just call it our term. And then we have, oh no, I wanted highlighter in green. And then we have a sub 1, which I hope you all already know is our first term. And if we were writing that as an ordered pair, it would be 1, comma, a1. And next we're moving on to r. You've seen r before, just not in this context, and r is our common ratio. It's that thing we get when we do what? We divide. We divide to get the common ratio. And then the last thing we want to look at is this sweet little n. And n is our term number. And the same rules apply to it that are applied in arithmetic sequences, and that is that it is a natural number. So it's not negative, it's not a fraction, it's not a decimal. Alright, and there's one thing here that we need to stress its importance, and that is the parentheses. These parentheses are super important because when you start plugging it into the calculator, it is going to mess everything up. Sorry, I'm having to look at how to spell parentheses. important. So yeah, make sure you always include those parentheses in everything. And also if you didn't, if you had a negative ratio, it might look more like subtraction. So always make sure you have that set of parentheses there at all times. All times. Woo! Alright, so now let's go ahead and look at a couple of examples. They're really not bad. So we want to write the equation for the nth term of the geometric sequence. So write the sequence as a table where n represents the term number and a sub n represents the value of the term. So again, let's take a minute to think about what these n's are. What is n? What is n, everybody? It's our term number. And what is a sub n? It's our term. So when they give us -2, -6, -18, -54, did they give us a term number or a term? You're right, they gave us a term. So we have -2, -6, -18, yes, and -54. Now we can place term numbers on those because all it is first, second, third, you know? So which one is my first term? -2. Which one's my second term? -6. And then -18 is my third. And -54 is my fourth. So now we want to find my first term. How hard is it going to be? It's literally just right here. So what's my first term? -2. Now I need to find my common ratio. So I personally say I like to always start at the end so I don't mess up my signs or anything, or I don't mess up my fractions if I have one. So let's start at the end of our sequence and move towards the front. So what is -54 divided by -18? I don't know about you, but I don't know that off the top of my head. -54 divided by -18. And what do we get? 3, yay! Now what's -18 divided by -6? And what do we get? Another 3. So far our ratio is in fact common because everyone has it. And then what is -6 divided by -2? And it is in fact 3. So what's my common ratio, everyone? 3. Alright, so now we want to plug in A and R into the equation to write the explicit equation. So this is just taking these two things and plugging them in. Did anything change about a sub n? No, bring it down. Don't forget about her, she's important. So a sub n, did anything change about the equal? Again, no. Bring it down. What changed the a sub 1? What is now a sub 1? You betcha it's -2. Alright, now what is important between a sub 1 and the ratios? The parentheses. So make sure you have your parentheses before you write your ratio. Alright, what the R changed to? It changed to 3. And then we need to make sure n minus 1 is up here in the exponent. Make sure it is in the exponent. That is all I ask. I actually ask a lot of things, like make sure there's parentheses and make sure your n minus 1 is in the exponent. All right. Now let's go ahead and look at another part of it that's not too bad. And that's it. That's the equation. So, all right. So now we want to use the explicit equation to find 7th term and the 9th term in the sequence. Now, what did they give us here? 7th and 9th are what? You betcha, they're term numbers. So that just means these will be plugged in for what? In. Very good. So looking at how it's written down here, a sub 7. So do you see where we used to have an n, we now have a what? 7. So we'll just plug in 7 in for the other n. So where did it go? We have -2 because we're using that equation times 3. And what's my new n? 7 minus 1. And don't try to sit there and solve this on your own. Just plug it into a calculator. Just do it. Plug it into a calculator. That's what they're for. So we're going to do -2. What's really important here? Parentheses. 3 to the 7 minus 1. And what I get? -1,458. So a sub 7 is equal to, don't like where my equal to signs are, is equal to -1,458. All right, now let's do the next one. We have a sub 9. Again, nothing has changed about the a sub 1. It's still -2. We still need the parentheses and 3, but now we're going to plug in what for n? 9, so 9 minus 1. All right, and let's type that in the calculator. This time I'll slow down. So let's start with the negative, not a -2, parentheses 3. And then to get the little exponent, we're just going to click this one key right here that looks like a housetop. I call it a caret key. I don't know why. To the n 9, which is going to be my new n, minus 1. And click enter. And we get this a sub 9 is equal to -13122. 13,122. 13,122. And that's all you gotta do. That's that. That's it. Alright, and now let's look at 1b. 1b says write the explicit and recursive equations for the geometric sequences. Sequence of 64, -32, 16, and -8. So let's start with figuring out what these sweet numbers are. Terms or term numbers. You betcha they're terms, so they're going to go in a sub n. So we have 64, and then we have -32, and then we have 16, and now we have -8. Alright, cool. So, and again, what's 64? Is that, what term number is it? 1. -32, 2. 16 is 3. And -8 is 4. So let's go down here and fill out some of this. What is a sub 1 again? What is my first term, everybody? You're right, it's 64. That first number in our sequence. So now let's find my r. And again, where do I start? The front or the back? You're right, the back. So -8 divided by 16. So I'm going to use a fraction bar because I think it's easier. So alpha y equals, and option number 1 of -8 over 16. And what do I get? -1/2. So right now I think my ratio is -1/2. But I want to keep going because I don't know, maybe it's not. Let's check 16 over -32. Alpha y equals 1. Not -16. Just 16 over -32. And what do I get? Again, -1 over 2. And lastly, let's do -32 over 64. So alpha y equal 1. -32 divided by 64. Why did I do that? And go down to the bottom. 64. And what do I get? -1/2. All these numbers are the same, so my common ratio has to be -1 over 2. Now let's write my equation. Remember, what's always my first thing? A sub n. And then what comes after that? Equals. Now what am I now going to plug in for A1? 64. What is super important between A1 and the R? Parentheses. And then what's my R? -1/2. And not -1/2 to the n minus 1. And there you go. That is how you write your equations. Now, before we part, I do want to help you out with one of your practice problems because I'm, kind of nice. Only kind of, though. Let's go ahead and look at practice problem number 8. Practice problem number 8. So, it says, given the explicit formula for a geometric sequence, find the first term, which is what? E1. Find the common ratio, which is R, and the term named in the problem. So let's look at 8. We have a sub n is equal to 2 times 1/4 to the n minus 1. So what's my a sub n? Or not my a sub n, my a sub 1. That's 2, that number right there in the front. And the r is going to be the number that has the exponent, n minus 1. So what's my r? 1/4. Alright, so now let's look at finding these terms. Remember, we replaced my tiny n with a 5, so we'll replace my other n with a 5. Let's plug it in. It should look like 2 times 1/4 to the 5 minus 1. Now let's plug that into our calculator. Alright, so 2 times y equal 1/4, and then caret to the 5 minus 1. And what do I get? 1/128. So a sub 5 is equal to 1/128. Alright, now let's do a sub 10. Why not? We'll have 2 times 1/4 times 10 minus 1. Oop, that got a little much. So 2 times alpha y equal 1/4 to the 10 minus 1. Alright, so that's kind of gross. I don't know. You can't really determine what my fraction is based on that, and I'm still not going to make you solve all of that by hand. But let's take a minute to remember something about geometric sequences. Let's try to plug in, we'll plug in 4 real quick. Let me delete this, and let's plug in 4. So we can see the pattern going on. So we have 2 times alpha y equals 1/4 to the, no, not divide, to the 4 minus 1. I'm just plugging in 4 so we can see the pattern that's happening. So let's talk first, like they're both fractions, obviously. Right, so what is, oh, that didn't mean to happen, sorry. So what is in the numerator or the top of both their fractions? 1. So I bet you can guess that 1 is going to be in the top of the fraction of the 10th term, right? So, but how did we get from this 32 to this 28? We multiplied by 4. So that means we can multiply 128 by 4 up until we get to 10. So that was the 5th term, so times 4. There's the 6th term, times 4. There's the 7th term, times 4. There's the 8th term, times 4. There's the 9th term, and times 4. And here's the 10th term. So it's going to be 1/131,072. Alright, and now I want to find a to the 13. We'll have 2 times 2 times 1/4 to the 13 minus 1. And again, since this was the 10th term, let's just multiply by 4 until we get to the 13th. So times 4, 10, 11, times 4, 12, and times 4. 13, 8, 8 million. So it's 1/8,388,608. And that's why I wanted to show you that. We were concerned that you might not be able to get those very big fractions in your calculators. So just remember the pattern. If they all have 1 in the top, or if even your ratio has 1 in the top, just multiply by the denominator in the bottom, and that'll help you out. All right, well, I hope that helped, and if you have any questions, please ask your teachers. They'd love to help you, and I hope you have a lovely, 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 lovely day. Goodbye.